So just all of you should have received the link to the slides in Slack. I've just put a few links in the first slide to where everybody's working, because we are only going to cover like one very simple use case here, and I'm sure there's much more advanced testing frameworks already in place in other plugins. And yeah, or maybe two things to mention here is on one of the things that I've been working on is the AiiDA plugin cutter. I don't know if you've already seen it. It's just a cookie cutter recipe for AiiDA plugins. And what we are going to look at is just the default output of this plugin cutter, which is called AiiDA diff. It's a super stupid plugin that just takes the diff executable and computes the diff between two files. So the reason I chose this is because diff is something that is already available on most Unix systems, and it's an example of a code that takes like one input file and another input file and produces an output file. And so, yeah, let's have a look. What did we want to do? So AiiDA diff uses for testing what is called the plugin fixtures. They are in aida.manage.fixtures. And what they provide for you is with a few lines of code, they set up for you a Postgres cluster. So meaning you don't even need to have already a database that you have access to. It will then set up a test profile, including database, and then load the dbenv and also provide functionality for resetting database between tests. And we will see how one way of using this in AiiDA diff. AiiDA diff uses pytest. There was some discussion a few months ago, and we concluded that we will recommend using pytest for testing plugins, although AiiDA internally still uses unit test. Pytest can be used to also run tests written in the unit test framework, and there's actually an example in AiiDA diff of this. I'm not going to show this, but there's a link to it. If you want to stay completely inside unit test, then there's a small hack you need to do. So, because if you want to use the plugin fixtures, because in essence, what you definitely want to avoid is that this setup of the whole DB cluster happens every time you create a test class, for example. And the only way to avoid this in unit test is to use a custom runner, a custom test runner. And again, here at the bottom of the slide, there's a link to a file that sets up a custom test runner for unit test that then can take care of that. Okay, so let's just have a brief look at the code. The tests are in AiiDA diff tests, and I should mention that so in pytest there's one Python file with a special meaning called conftest.py, and this is where you connect to the AiiDA fixtures. So here we see the import from aida.manage.fixtures, import the fixture manager. And what we see here is a so-called pytest fixture. It's called AiiDA profile. It says scope session, and this means that this will run only once for a test session. So the setting up all the database and everything will only run. Will only run once when you run the tests. And what does it do? It creates this fixture manager and yields it back. So this is something that you can simply copy paste, put into your conftest.py, and then we will see later how to use this AiiDA profile fixture in your test functions. There's another simple example of a fixture. It's called new database. Here again, here there's a different scope. It's on a function level, which the purpose of this is to reset the database in between tests. So this function does first nothing, then it goes. So then your test will run, and at the end, after your test is run, we go after this, what is written here, in yield, and it will use the AiiDA profile test fixture, which it takes as an input here, and use it to reset the DB. Also, this is something that you can simply copy-paste. You already noticed that I'm not an expert of pytest. And this actually was contributed by Chris here to the AiiDA diff plugin. Yeah, so there's lots of more cool things you can do with pytest. Again, there's much bigger experts here than me. And we'll just have a quick look at how to use these fixtures in a test. So we go into the tests, calculation tests. So pytest, like unit test, will just pick up tests from files that start with test underscore, for example. And here we have a simple test function. This simply gives a tag to this test called process execution, which allows you to, for example, skip all process execution tests when you run them, or only run the process execution tests, and so on. And here's some strange Python magic going on that pytest does, right? So it gets this new database, which we defined before in the conftest.py, and the new workdir fixture we defined in conftest.py. There's no import here. So pytest somehow injects these fixtures into this code. I don't know about the details. I'm sure there's lots of details to talk about if you're interested. But if you want to know, if you want to know more, ask the people who know more. If you don't need to know more, you can essentially get access to the fixtures that you define in your conftest.py in every test that you write. What are we going to do here? So we are going to use this new work directory, temporary directory that we've created to set up our computer. Again, this is a simple function, get computer, that is located in the init.py of the tests. I'm not going to show how this is implemented, but you can again copy it if you want to. And then we are going to set up a code for the entry point called diff on this computer. And then we are going to simply create a calculation. So I have a special parameter data type here called diff parameters. I create the input file and the other input file that I want to compare. And I create the options for the calculation, as well as the inputs of my calculation. So these input parameters, one single file data, another single file data. And then I simply run the calculation and do a very simple test on the resulting data. So the data will be put into this diff output, which is a single file data again. So I get the content of this diff output and then check whether these two, the content 1, which was in the first file, and content 2, which was in the second file, are inside this diff. I could do a much better test here. So that is one way of doing a full test of, let's say, so to say, an integration test of your executable that includes running the executable and producing a result. Let's go back to the slides. Are we already here? Okay. And now, one thing you can do is you can, I think, who has not yet set up automatic tests on Travis? Everybody has set up. You know how to do it, but you haven't done it yet. Okay, so then I don't need to.
I did it right, then I didn't.
Okay, so then let me just show a quick example of the travis.yml file that I'm using here. So with 1.0, AiiDA 1.0, we now need not only PostgreSQL but also RabbitMQ. This is provided by Travis, so there's nothing for us to do. Here I'm just defining. I have a script that clones AiiDA from the core repository and checks out this particular Git hash, which is kind of a workaround for the moment. Later on, we will simply be able to use just a tag from PyPy. there's like an example of a build matrix. So I'm testing, for example, Python 2.7. I'm testing here the default, if I don't specify, is the Django backend. I'm testing the SQLA backend. Then here I'm testing pre-commit. And then again, I'm testing all of these things on Python 3.6. I don't think there's anything very special. Here's maybe one nice thing is there's this like a plugin for coveralls for pytest that can then for coverage that can then tell you how well these tests that you're running cover your code base. And then we can have a quick look at the output of this. So if you then look on Travis, this is what you get. So you will get for every file that you've run, I mean, how much of the lines are covered by your tests. Again, nobody can see anything, I guess. All right. Then, yeah, so there's a few things that are still on the to-do list. One is a suggestion by Bonan. Currently, the fixtures always create this database cluster and create your test profile, etc. And this takes a few seconds. So on my machine, I think it takes maybe 5 seconds. I haven't benchmarked it on Bonan's machine. Apparently, it took 20 seconds or something like this. And so this is something you might not always want to do, in particular if you just want to run one small test or so. So what we plan to do is we plan to do something like an environment variable that you can set to tell the fixtures, I already have a test profile. Don't try to set up all of this stuff. Just use this existing test profile. So this is one thing we'd like to do, and there's a link to the issue where we are going to discuss this. Second thing is, yeah, so at the moment these fixtures, as you can see, are living in the plugin cutter, but it would be very nice if we would expose, if we would provide these fixtures directly from AiiDA core. We could do this by an entry point, so these are suggestions from Chris, who also has some ideas on how to make this even more user-friendly so that you don't have to then figure out where you have your get computer and get code functions, but you simply get back a class from the fixtures that has all of these functions as methods, essentially. Again, and here's the link to the issue where we're going to discuss this. And third is, yeah, so currently we are, my approach here is using Travis directly. So these things are running in the container that Travis provides, while it might be interesting for some use cases to already have a pre-built container, so that, for example, here, every time my tests run, I have to install AiiDA core. And if we want to get rid of this, we might think about providing a Docker image that already contains AiiDA core ready for tests, so that you can simply, you can use the Docker service on Travis. You can then inside Docker, inside your travis.yml, create a container from this Docker image, and then run your tests in there with significantly reduced setup.